All right, my name is Myron Loewen, and it's by divine providence I get to stand before you today representing Solidigm. I'm glad our PCs worked and friendly people were able to switch slots with me. Manageability isn't something that gets a whole lot of publicity. It's in the back corner. If it fails, everybody knows about it, but until then, nobody cares. I want to show some things today that I think are important in that path, and hopefully you guys can follow the call to action at the end. All right, so this story starts, let's say 2014, a long time ago. We were building our first NVMe SSD, and this new exciting thing called SMBus was on these wires. Before that, we had to blink out power on, your temperature on the LED, and everybody had their own little pattern. Apple wanted it this way, and Dell wanted it this way. And now here we get SMBus, and we get a way to send out the temperature and some other data. And we tried to come up with an industry spec on how this is going to happen. And before we could have it ready, we were shipping product, and customers were saying, hey, we need to have this temperature data. And the spec was taking too long, so I graciously came up with this format, which stuck with you guys. You guys loved it and adopted it and extended it, and we're still using it today, 8 years later. And there's a little picture at the bottom of all the different data that's included, but you guys have added power, capacity, version, and model at OCP. My plea today, and the whole rest of this presentation, is to convince you that it's time to let this one go. And not that you have to get rid of it. You can keep using it, but please, let's stop extending it, because now we're splitting engineering resources trying to extend it here, while there's other ways to do it that I'm going to show in the next slides. And so this is alternative number one. This is the one I recommend. There's another alternative called PLDM. We won't talk about that one much today. But NVMe EMI has been going into its 4th generation. It's got all these different rich command sets down below at the bottom. They'll solve almost every possible need you have for manageability of an SSD or other storage devices, even storage chassis. I won't go into any of the specifics. You guys can ask me about that later if you're interested. But it's a simple command response model. You just send it a command that gives you back your results. And it uses the management component transport protocol, which is MCTP. MCTP is used by a whole bunch more. If you look in the bottom right corner, there's a bunch more things that use MCTP. We're not alone in that path. That's why we picked that one as the transport protocol to use. If we look at right in the center, there's that kind of a little bar across the top. On the far left, you see there's a physical header, and then there's 4 bytes of data down the middle, and they're broken out at the bottom. There's basically a destination and source endpoint, so it's really not very complicated to add. Not a whole lot more complicated than the basic we saw on the previous page, but it gives you a whole rich new supply of power that you can use for security and for other things that I'm going to show. So my slides are a bit big for this screen, but we can see everything that's important. All right, so some of the new things that are coming. If we can make the switch from basic to MCTP, there's these 5 new things that are coming down the pipe to help us. One is human-readable through information data. So in the past, we had a VPD, and it had some binary encoded data in it. People were very scared to pick it up, modify it, and write it back to the drive because they might mess up the binary format, and they have to get everything right. So it's going to be a lot simpler with this new data that's coming. Plus, you'll be able to look at it and just, with your eye, figure out if something's wrong instead of having to decode it with some software. Also coming is device-initiated alerts. This is kind of like over PCIe, you can send announcements of status changes. And in the past, you had to poll the SSDs. This will let you get alert from the SSD when the temperature goes over. MCTP2 is coming with a lot new stuff like encryption. It's going to get flow control, which takes some of the stuff from NVMe MI, and it brings it up to the MCTP layer where it belonged in the first place. SNIA and PCR are collaborating on the I3C migration, which Anthony just talked about earlier. And there's also some MIPI I3C speed improvements that are coming. So when you see BASIC there, don't get that BASIC confused with the NVMe BASIC. These are two different things. MIPI I3C BASIC is the free version of I3C that MIPI is released for general use. If you want the full I3C, then you have to be a MIPI member to use that. All right, so here's a quick peek at what I3C looks like. If you see the different things along the bottom, there's 4 different kind of strips. There is a direct get, broadcast, a private write, an interrupt, and a private read. This looks very much like SMBus, where you send an address, you get an acknowledge. That first part is exactly the same as SMBus. After that, it gets a little different, and I circled the differences in red. For example, the first line there where it says last, instead of sending a parity bit, which requires the bus to switch directions and slows things down, we're just going to send whether there's more bits coming or not. And when the other direction is sending, you see in the gold one line lower, it's going to use that position to send parity for extra error correction. All right, so this I3C BASIC is already a thriving ecosystem in cell phones. It solves the MUX issues on PCs, and it's compatible with SMBus for the things shown there, like speed, interrupts, resets. And the exciting thing I get to show you today, this is hot off the press. We have a demo running right now at Intel. And you can see here how the 3.3 volts steps down to 1.8. This is part of what Anthony was talking about earlier. There's a protocol where we figured out how to negotiate this. So on the top, kind of a strip there, there's a 400 kilohertz SMBus sending the 7E. The drive acknowledges that, and then you can see at the bottom, after the voltage has switched, that red circle in the background is this burst of traffic here. And you can see it's jumped up to 12.5 megahertz. So much, much faster, 20x faster. And that's if you're using 400 kilohertz. Most people are still using 100 kilohertz for SMBus. So this is just excitement to show you that I3C is coming. It's working. And if you look at the slide deck later, at the bottom, it'll tell you the different pieces of hardware that were used to make this. It's all off the shelf. So the call to action is that I'm pleading with you to switch from extending BASIC. That means please don't implement something like the secure firmware recovery, which uses the BASIC model, and instead use many of the, there's at least 2 great firmware update models, one from NVMe MI and another one from PLDM. Use something that exists instead of creating something new. And let's migrate to BASIC plus MI for SPDM, security, telemetry, and all those other good features I just shared, and prepare for I3C becoming a wholesale displacement for SMBus around 2025. Obviously, I can't predict the future, but that's where we're guessing it's going to land. If you have any questions, this is your chance.
Go up to the mic, you can ask a question. Any questions?
If not, you can catch me later, and I will give you a free consult if you have anything more you want to add to SMBus, or come join one of the different communities where we're defining these specs.